Thomas Zirin, previous NASA science chief, remarked on the send-off of the James Webb Space Telescope, JWST. James Webb denotes the start of a new period in space science. Webb will grow and test our cosmology and our comprehension of planets and the beginning of life. What started ideally transformed into a catastrophe. James Webb stunned researchers with the emergency. Now, with another disclosure of the James Webb Telescope and the discussion in physical science, the conversations about old speculations and who is thinking correctly or wrong could, without a doubt, be reaching a brief conclusion. Yet, what precisely does this mean? Have researchers truly unwound the secret? It's difficult to encompass James Webb's revelations? Or are we simply being slowed down with unstable clarifications? James Webb was expected to bring solutions, yet, all things considered, the $11 billion venture plunged cosmology into a significant emergency. All pieces of normal science related to space are now experiencing a purge of the kind we last saw in the Middle Ages with the shift to the heliocentric perspective on the world. Now we might need to recognize that the underpinnings of our cutting-edge physical science are likewise defective, and that we have not come close to understanding what our universe truly is. How is this conceivable? The present astronomy, or in other words, the study of the physical amounts and connections in the universe, depends on the fundamental guidelines of physics which basically return to scientists of ancient times, the Middle Ages, and specifically to Sir Isaac Newton. The primary perceptions of mechanics and elements were made in times long past. Amounts and powers were described for the first time, and later Newton discovered gravity, which is so significant for astronomy that we built our scientific perception of the universe on these foundations. We moved the amounts and powers that were valid and recognizable on Earth to the universe. This created some predictable results, but then the space we can see got increasingly big and, at a certain point, our known amounts no longer fit to describe what we see. This emergency began with an issue. The unique techniques for estimating the age and development pace of the universe led to problematic outcomes. Nearby estimations based on galactic objects within the universe gave unexpected qualities compared to estimations of the early universe based on the astronomical microwave background radiation. We know this cacophony as the Hubble strain. While the Hubble constant demonstrates the development pace of the universe, in the summer of 2022, Webb found so many old and highly developed galaxies in space that questions emerged regarding how the age of the universe was resolved. Our universe can hardly be 13.8 billion years old if, on account of Webb, we see galaxies that were already advanced 200 to 100 million years after the Big Bang. According to the computations of our physical science, galaxies need billions of years to form. In the case of the galaxies found by Webb, this would even imply that the time of their formation was before the Big Bang. Our old cosmology, according to which the universe began with a Big Bang 13.8 billion years ago and has been expanding ever since, and has gone through a slow process of matter development, can't be right. We are at a junction. Either we are committing an error if we assume that our natural physical science can be applied to the whole universe, or we have up to this point only interpreted a little piece of the physical science that truly exists. The old researcher Hermes Trismegistus once said, "As in small things, so in great things." According to this proverb, all the physical science that exists in the universe should also be found on Earth. But maybe we have ignored forces and aspects on our planet that we are now seeing in the universe. Webb breaks all records. It's fabulous. This telescope can capture very weak light signals. Webb's 18 honeycomb-shaped mirrors easily detect light that has traveled through existence for over 13 billion years. A unique exposure technique makes these faint traces of light apparent for the first time thanks to the new revolutionary technology. We saw the light from the most distant galaxies that formed shortly after the Big Bang. In the summer of 2022, these galaxies were a sensation and, simultaneously, a severe frustration. Rather than infant galaxies, Webb shows perfectly developed galaxies that seem to be a few billion years old with an age of 13.5 or 13.6 billion years. This can't be the case. Nowadays, researchers sometimes say that the objects and the images aren't impossible or not real, but Webb can show us reality. Science must now admit that it has likely been on the wrong track for over 100 years. That's generally how old our standard cosmological model is. Webb works perfectly. It's just that huge pieces of our science are still incapable of handling the new insights. Some of the old conservatives who would rather not face the new insights eagerly opposed the end of the Big Bang or the idea of expanding particles. In the Middle Ages, it also took many years before the Church was finally able to admit that the Earth was not the center of the universe, despite the sudden masses of evidence from astronomers across Europe. So not much seems to have changed. And even though we see ourselves as so much more modern today, we have a similar situation. Scientists who broadcast something new may no longer end up in jail like Galileo Galilei, but the struggles among scientists and the opposition to new things are still there. Imagine you have spent a lifetime looking and firmly believing in something, and then suddenly you see pictures or another side of reality that tells a different story. Maybe your mind would also resist this at first, and it would take some time before you could accept the new truth. Many liberal and young scientists are excited about Webb's revelations. Rohan Naidu, the pioneer of the G-class C1 world, and S. Finnan, who found Mama World, belong to this liberal generation of scientists. They see Webb's pictures with an open mind and have been studying them since the first moments of publication. However, was it Hubble's fault? We should investigate. One of the great debates in modern cosmology concerns the Hubble constant. This is the rate at which the universe is supposedly expanding. In the 1920s, cosmologist Edwin Hubble discovered that distant galaxies were moving away from us. From this, he inferred that the universe is expanding. The idea was later developed, and the Belgian cosmologist Lemaitre proposed that this expansion began from a single point, the Big Bang. Today, we definitely know from alternative methods that the development of galaxies can also be explained differently, and these approaches also provide a coherent picture. However, they were overlooked for a long time because the old theories were considered more plausible. But the more we see of the universe, the more errors arise. This didn't just start with Webb. Indeed, even quite a while ago, there were regions in space where the expansion was acting differently. Maybe these regions were sometimes faster and sometimes slower, or maybe denser or emptier. This led to the hypothesis that there might have been several starting points or that our universe is even forever influenced by a few sources, which don't necessarily all have to have had a start at the same time. Alternative thoughts about the shape, nature, and age of the universe arose. However, scientists continued to cling to the old hypotheses of the Big Bang and expansion. This was possibly a mistake. We have now briefly learned about the Hubble tension. In short, it shows clear differences in distance measurements in the universe depending on which fixed points we use as measurement constants. Now researchers hope that the Webb telescope, as its mission advances, will be able to resolve this tension by making precise measurements of the distances and redshifts of galaxies. The potential correction of errors in past measurement techniques not only represents a significant turning point, but also holds the promise of ushering us into a new era of cutting-edge physics that delves into the very fabric of astronomical reality. This grand achievement stands as a testament to the enduring commitment and eager persistence of generations of scientists who have dedicated their lives to unraveling the mysterious secrets of the universe, relentlessly pushing the boundaries of human knowledge. Throughout their quest for truth and understanding, these bold adventurers have not only expanded the horizons of our comprehension of the universe, but have also enriched our shared perspective, igniting a sense of wonder and awe at the vastness and complexity of the universe that surrounds us. As we stand on the threshold of this new frontier, poised on the edge of discovery, it is incumbent upon us to approach each new revelation with receptive minds and open hearts, embracing the potential of even the most novel or surprising discoveries to reshape our understanding of the universe in profound and unexpected ways. Indeed, the emergence of new hypotheses and alternative explanations signals the dawn of a new era in scientific inquiry, where entrenched principles are challenged and bold new ideas beckon us forward into uncharted realms of knowledge and exploration. At this pivotal moment in history, we find ourselves on the cusp of a significant scientific transformation, where the investigation of the oldest pockets of light in the universe holds the tantalizing promise of unlocking the deepest insights into the nature of existence itself. With the aid of cutting-edge technologies such as the James Webb Space Telescope, we are poised to embark on an extraordinary journey of discovery, delving ever deeper into the cosmic tapestry to unravel the mysteries of accretion disks, probe the enigmatic realms of supermassive black holes, and peel back the layers of cosmic phenomena that shape the very fabric of our universe. Yet, as we chart this bold course into the unknown, we must also tread carefully, mindful of the complexities and uncertainties that lie ahead. For each new discovery brings with it a host of new questions and challenges, inviting us to venture further into the chasm of the unexplored and confront the mysteries that have eluded us thus far. In the grand tapestry of cosmic evolution, each